All right, the binomial theorem here, and maybe it doesn't seem once you look through it why it's included in this, but the connection is made once we start looking at probability. This is just looking at patterns in expansion of binomials that look like that. Not necessarily A and B, but that's just for symbolically for right now. As a start, we need to think about what this means here. What this is looking at is maybe if you think back to grade 8 or 9 when you might have learned to do that, learned to multiply that out. Let's start with something that might look more like what you did in grade, well, let's use a number like 3. Okay, that looks more like something that you might have done in grade 9. Grade 9's, what's the common wrong answer they put for that? So this is not what it's equal to. What is it? X squared plus 9, right? That's part of the answer, but it's not all of the answer. If you actually make a visual of it here, if you think about it as the area of a square, this is x plus 3, right? So that length on the side there, that length is x plus 3. And this length is x plus 3. If you just do x squared plus 9, what you're really only getting is part of the area, right? You're getting x squared here, and you're getting 9 here, but you're missing these two things. What are those two pieces that you're missing? Yeah, 3x over here, 3x over here. So really this has got to be equal to x squared plus 6x plus 9. That middle term is what people forget all the time. Not all the time, but... And then once you realize that, I mean, really what you're doing is, because for grade 9s, if you write it out the long way, then they say, oh, I get it. Yeah, you have to, they see why they need that middle term. And maybe once you get to that point, you realize that, because if you ask grade 9s, they don't see that this is any harder. If you put like 23 here, they don't see that this is a lot harder than this, right? Why is that a lot harder? Let's make it a little bit simpler. Why is it harder to do this than this? Yeah, you have 3 of them, right? Like you have to take, you have to multiply out 2 of them and then get an answer for that and multiply by the next one, right? If you had x plus 3 all the way across here. So, because you'd have to multiply these, now we just did it up there, x squared plus 6x plus 9. And then you'd have to multiply it by this. It's going to be each of these things times each of those, all right? If we left this as the long way over here, plus 3x plus 3x, like if we didn't combine things together, really what you're ending up doing there is, how many terms would you end up getting here? So many. How many? You'd have how many? 8. You'd have 8 terms, right? So if you think about it, like you're going to have 8 terms here. Now let's write them out because I think it's going to help you understand here. You have x to the third is going to be the first one. If we do this in an organized way, like we do x times each of them, and then 3 times each of them, the first one's going to be x cubed. What's the last one going to be? I'm going to switch to using a's and b's here in a second so we can keep track of this. There's going to be 8 terms. Let's just agree there's going to be 8 terms here. Each term is going to come from one pairing of each of these things, right? X cubed comes from doing the x times the x times the x. What would the very last term, if I did this in an organized way, be? It would be 27, right? Where would that come from? 3 times 3 times 3, right? Each of the other terms is going to come from pairing it up somehow. Okay? There's going to be a term that's x times 3x, which is going to be 3x squared. How many times is that term going to appear? It's actually going to appear how many times? Because it's going to appear from there, but there's one more place it's going to come from. It's going to come from here as well, right? There's going to be 3 times that 3x squared occurs. There's 3 ways you can get a 3x squared out of these 3 brackets. You can take an x out of here, an x out of here, and the 3 out of there. Or you can change that around. You could take the x out of there, the 3 out of there, and the x out of there. Or the third way would be if I started the 3 out of there and then the 2 x's out of there. It's 3 times that this comes up because there's 3 ways I can pair those up to get 3 times x times x. There's only one way you can get x to the third out of those three brackets. What's the only way? Yeah, 1x from each bracket, right? There's only one way that can happen. And there's only one way you can get a 27 on the end. What's the only way you can get the 27? 3 out of each bracket, right? Now, we've done 5 of the terms. There's really a couple more. What would the other terms be? So we have 3 times we're going to get 3x squared. So I'm going to move this so I keep track of it here. What's the, 9x is the other one, right? How many different ways am I going to get 9x here? I'm going to get it once from this. Yeah, and then I'm going to get it once from 3 times 3x. And I'm going to get it once from 3 times 3x. There would actually be 3 of these, right? There's your 8 terms, right? You have 8 terms there, okay? Now, I realize that anytime you've ever done this before, you would have probably added this together before you did that, but you might not notice the pattern then. There's 8 terms because there's 8 ways you can pair these things up. If you have 3 brackets here, there's 8 ways you can pair them up. If you choose one thing or the other from each bracket, right? There's 2 things you can choose from the first bracket, there's 2 things you can choose from the second bracket, and there's 2 things you can choose from the third. There's 8 different ways you can pair the 2 terms up in there when you're multiplying, right? Because essentially, just like before, if you ask a grade 9, they say, when they multiply out 2 brackets here, they say, oh, it's easy. You just have to do each of these times each of these, right? Each of these times each of these. When you have 3 of them, it's the same way. It's just that you need each of those times each of those times each of those. You need every possible combination. If you have 2 brackets, there's 4 combinations because there's 2 there and 2 there. If there's 3 brackets, there's 8 combinations. There's 8 ways you can pair the things up. And it's going to be spread across this. There's 1 way you can get this. There's 3 ways you can get that, 3 ways you can get that, and 1 way you can get that for any binomial here. If we added another bracket, it would be the same way. We'd have more terms. How many terms would you have if you had 4 brackets? You'd have 16, right? Some of them are always going to be able to be lumped together. Okay? If we had another one, the middle ones are the ones that end up being able to get lumped together, but the end ones are always going to be only one way to get that. All right? So what I would like you to do, I did give you some space on there to do this, but I want you to try, and you can write it where I left it there for you. I think it helps by doing this without adding the terms together, like without adding the 3x and the 3x before you multiply this, because it helps you see the pattern better. So when you're multiplying out, let's do A's and B's here. Like if we're doing A plus B to the third, really again we're doing A plus B, A plus B, A plus B. So if we multiply this out, we get, if you do the first 2, you get A squared plus AB plus AB plus B squared, right? That's the first thing, but right now I don't want to add this together. I realize that would be what you got up here, right? If you had A plus B times A plus B, you get A squared plus 2AB, right? If you added those 2 middle 2 together. Okay, so that's what it would be if it was all simplified in the end. But let's keep it written out the long way here for a second, because then it's easier to see where the different terms come from. What do we have here if we have this all simplified? The third one here. You got A to the third, right? What's the very last term going to be? That's the other easy one. B to the third. The ones in the middle, so the ones, what types of terms are you going to get here? You're going to get A times, you're going to get A squared B how many different ways? You're going to get A times AB gives you A squared B. You get A squared B. How many different ways you get that, did you say? 3 different ways, right? Because you could take the B and the A squared, or you can take the A and the AB. There's 3 different ways you get this. And then what are the other? Yeah, the AB squared. And how many ways does that happen? 3 different ways, right? Now, obviously, that's not the normal way you write it out, but I do want you to see the pattern here. There's 1 way you can get that. There's 3 ways you can get this. There are 3 ways you can get this. Thank you. I'm going to wrap it up here. There's that many ways you can get that. If it's simplified, it's going to say a cubed plus 3a squared b plus 3ab squared plus b to the third. If you look at the coefficients, there's 1 on the front even though you don't write it, and there's a 1 on the last part here. You don't write it. Those come up in Pascal's triangle precisely because it's the ways you can pair things up like that. All right? Can you do ab to the fourth like that, please?